So this is the first problem of today's Div 3, and in this problem we given that Rudolph is going to visit Bernard and he decided to take the metro to get to him. Now the ticket can be purchased at a machine that accepts exactly 2 coins and the sum of which should not exceed k. So in Rudolph's, like in one pocket he has n coins with the denominations b1 to bn, and in the right pocket, that is in the other pocket, he has m coins with the denominations c1 to cm. Now he wants to choose exactly one coin from the left pocket and one from the right, such that the sum of those is less than or equals to k. So we have to find the total number of ways such that he can do this thing. So if we look at the constraints, there are 100 test cases and the number of coins in his both of his pockets is less than or equals to 100. So let's say we're given some n values and some m values. So we just have to find, let's say this is F array and the second one is C array C. So we just need to find for how many i's and j's the following is true. Now there are many ways to do this. We can sort the first array, apply binary search, but for this problem, since the constraints are that the number of test cases will be less than or equals to 100 and the size of this array is less than or equals to 100, along with the size of this array is also less than or equals to 100. So we can just brute force, like check for each and every pair, and there will be around like at max 100 into 100 pair, and this will be done in worst case for every test case. So we'll have at max 10 to the power 6 operations. So what we'll do, we'll iterate our I over this array, and for each and every possible value of I, we'll iterate the j from starting to ending, and we'll check whether this thing is true or not. If it is, we'll increase our answer by 1. Is it making sense? Yes, no? Okay, so let me show you the implementation. So in this, I have first taken n, m, and k as input. Then I have taken vector A and vector B as input. Then I have initialized my answer as 0. And for every value in array A, I'm iterating through my array B. And I'm checking whether this is true or not. If it is, I'll increase my answer by 1. Finally, I can print my answer. Is it clear? Okay, so let's move to the next problem. So in the next problem, we're given that Rudolph has an array A of n integers and the elements are numbered from 1 to n. Now in one operation, he can choose an index I between 2 to n minus 1, and from the previous index subtract 1, from this index subtract 2, and from the next index subtract 1. So now Rudolph can apply this operation any number of times, and at any index I can be used. This operation can be applied many times, and it can be applied more than once on a given index I. And finally, we need to find whether it's possible to make all the elements 0 or not. So we're given an array. So let's take one example. So let's say this is the, so first Rudolph will choose this thing. We'll have, so from this 2 will be subtracted, so we'll get 1. From this 1 will be subtracted, so 4. So let's say then Rudolph shows us this 0, 0, 2, 1, 2, 4, 2, and then choose this twice. So this will become -1, -1, 0, -2, -2, 0, and -1, -1, 0. These were already 0. So everything is 0. So we have to find this thing, like whether this is possible or not. Now, if you look at this, if you have an array like this, you can only, your I can be only these, one of these. You cannot choose this as your I or this as your I. So tell me one thing, if let's say you have X here, what should be the I? Like this should be, chosen at exactly X times, because if it is less than X, you'll have non-zero value here. If it is more than X, if this value of I is chosen more than X, you'll get negative value here. So this should be exactly X. You'll get 0 here. Here, you'll get the value with whatever here is -2X, and here you'll get -X. Is this thing making sense? Now, let's say here there was initially Y, here there was initially Z. So now the new array, after this kind of operation, after you've done these X operations, you'll get something like 0, Y minus 2X, and the remaining array. So now you cannot choose this I, because otherwise this will become negative. So this is exactly like earlier. Just ignore this. Now you have to choose this, and how many times you have to choose this? If let's say this value is alpha, you need to choose this I as alpha times, or Y minus 2X times, exactly, right? Yes, no. And like this, we can check for every, like we have the fixed way of doing these operations. So we can do this for every I from here to here, and finally check that every value is 0 and none of the values is negative. Why negative? Like some values can become negative because, see, I subtracted from this X. I didn't check this value Z. I just subtracted X from it, and then I would subtract this alpha Y minus 2X also. Like I would subtract twice of Y minus X. So when I come to here, when finally, like I need to check that this value is not negative. So if every value is finally, like after doing these operations, every value is 0, then yes, the answer exists. Otherwise, the answer doesn't exist. Is it clear? Okay. So let me show you the implementation. So this is the implementation. In this, I have first taken array A as input, then this is my flag, whether the answer is possible or not. So I'm iterating from starting and I'm going till the third last. So first of all, I'm checking if the current value becomes negative somehow, then the answer is not possible. Like I'll simply break, I don't have to do anything. Otherwise, this is my current value, right? So I'll do exactly these many operations by choosing the next I, whichever is after I have I plus 1. So I'll do AI operations by choosing that as my index. So from that index, this much will be subtracted. From the index which is after this chosen index, this AI will be subtracted. And from AI also, AI will be subtracted. So AI will become 0. Like you can do it like this also. This was I plus 1 is my chosen index, and I'm doing AI operations. So finally, after this loop, I just need to check that the count of zeros in my array should be exactly equals to n. That is, everything should be 0. If it is, finally my answer is yes. Otherwise, the answer is no. Any doubts in this? What about others? Okay, so let's, like, okay, somebody has some doubt. See, in this, your operations are fixed. If you start from first, there is only one way, that you can make it 0 by choosing the next index. That is, if you want to make this as 0, you have only one way, that is choose this index exactly this many number of times. Once this becomes 0, you'll have to make this as 0, and for that also you have just one way, that is choose this index exactly this many number of times, that is whatever is remaining. So this way you can start from here and move all the way up till the last position. And finally, if the value is of every element is 0, you have your answer. Otherwise, you can simply print no. Is it clear? Like I don't have to use flag here. There it is not being used. Any other doubts? Okay, so let's move to the next problem. So in the next problem, we are given that Rudolph has a string S of length n, and Rudolph considers this string S to be ugly if it contains substring pi or substring map. Otherwise, the string S will be considered beautiful. So for example, this has pi as the substring, this has map as the substring, this has both pi and map as substring. So they are ugly. Otherwise, this is doesn't have pi. This also doesn't have pi as a substring. It has PIIE, not PIE. So these are beautiful. So now we need to find what is the minimum number of characters that we need to remove from string S in order to make it beautiful. So that is, given a string S, we need to find the minimum number of characters that we need to remove so that there is no occurrence of pi and map. So let's say there's a string. If let's say anywhere we are getting PIE, we can always remove one occurrence of pi by removing the middle I. Right? Similarly, for map, we can remove its occurrence by removing this A. Anyone having any doubt in these two things? Like one occurrence of pi and one occurrence of map can be removed by just one operation. Remove the centermost character. Don't say that like you can in some maybe it's possible to remove this E also, but it's always optimal to remove I because it's also possible that after E there's another E. So, but still there will always be one way to get exactly one operation, that is remove the centermost. But there is one corner case scenario when you have something like, so you have substring map also and pi also. So in this, you can just remove this p, and both of these occurrences, map and pi, will be like you won't get map and pi here. So just one operation to remove both here, and otherwise one operation for these. So in your string, you can just check if you're getting MAPIE, then add one operation and just shift your, like ignore that string. Otherwise, if you're getting pi, increase your answer by one. That is, you'll have to remove one character and shift your iterator to this point, like that is to this index. Otherwise, for map, also you need to increase by one. Is it making sense? Okay, anyone having any doubt in this? Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken n as input, then I have taken string s as input. Initially, my answer is set to 0. Then I'm iterating from 0 to n minus 2. Why n minus 2? Because technically, I don't have to go to the last and second last character. Because map and pi are both substrings of size 3. So I'm checking I plus 1 and I plus 2. If they are pi, increase your answer by 1 and skip the next two characters. Otherwise, first check for this thing that you have MAPIE. So I plus 4 is less than n. Here I'm not checking I plus 2 is less than n because of this. But here I'm checking I plus 4 is less than n, and I'm checking for the next 5 characters. next four characters are this, and I'll increase my answer by one, and I'll skip the next four characters. Otherwise, if this is not true, I'm checking for map. If I have map, I will increase my answer by one and skip the next two characters. Here, I can directly do this pi without checking anything else, because if I'm getting pi, it's definitely I didn't have map before it. Because if I had map and then pi, then definitely I would have got that thing here. Is it making sense? No doubts, right? So let's move to the next problem. So in the next problem, we're given that Rudolph and Bernard decided to play a game with their friends. Now, N people started in a circle and started throwing a ball to each other. Now, they are numbered from 1 to n in clockwise order, and let's call a transition of movement of the ball from one player to his neighbor. And the transition can be made either in clockwise direction or counterclockwise. So let's call the counterclockwise distance or clockwise distance from player y1 to y2 as a number of transitions in clockwise or counterclockwise, and counterclockwise that they need to made to move from y1 to y2. So I'll explain this in a moment. But what we have to do, let's say, see, let's say there are n like this. Now, let's say the ball is with this person. Initially, you'll be given that okay, some person has this ball. Now, after this, there will be some rounds, and either this person can throw this ball clockwise. Let's say in clockwise direction, the distance that this ball is thrown is 3. If it is counterclockwise, the ball would be thrown to this person. So for clockwise, let's say the character that denotes clockwise throw, it's this. For counterclockwise, it's this. And for direction unknown is this. So then in that case, the ball can end up with both of these persons, like any of these persons. So what we are given, initially we are given that some person had the ball, and after that we are given the information regarding m rounds. So for each of these rounds, we are given two things. That is, we are given two things. That the first thing is the distance at which the ith. Okay, we are given two things. That is, the first is the distance at which the ball is thrown, and the second is that either it is in clockwise, counterclockwise, or the direction is unknown. Like in that case, the ball can be thrown in both. Like we'll assume that it goes in both. So okay, so in like first we are given n, m and x. N is the number of players, m is the total number of rounds, and x is the starting person. And after that we are given r and c, like m values of r and c. For each round, r is the distance that the ball was thrown, and c is the direction. So if it is 0, it was thrown in clockwise direction. If it is 1, it was thrown in counterclockwise direction. And if it is 0, if it is question mark, then we don't know. So let's take an example to understand this. Let's say 632 given, and just this thing. So see, initially there are 6 people. Initially there will be 3 rounds and there is ball is with the second person. So let's say this is 1, 2, 3. So after like initially ball is with this person. Then like the ball was thrown at a distance of 2 and the direction is not known. So either it will be thrown to this person or this person. Is it making sense? Yes, no. Like either after first round the ball is with 6 or 2. Then after second round, let's assume if it was at 6, it will be thrown to either 2 or 4. And if it was at fourth person, it will be either thrown at 6th or again 2. Right? So after second round, it is either at 6 or with 2 or with 4. The ball, right? After second round. Is it making sense? And after the third round, this 6th person will either throw the ball at second or at fourth. Fourth will either throw at 6 or 2. 2 will either throw it at 6 or 4. So finally, after 3 rounds, the ball is either with at 2 or 4 or 6. So this is what we need to create. Is it making sense? So now if we look at the problem constraints, see, we are given that the sum of n into m, that is this thing, cannot exceed 2 into 10 to the power 5. So this is a simple now, like because of this, the problem becomes simply brute force. Why? See, there will be a total m rounds, and if let's say the ith person has the ball, in worst case, it can throw to 2 persons, either I plus x, like what in clockwise direction, it will be at I plus x mod n, or in counterclockwise. So we'll write that down in a moment. Here I'm assuming that the I is starting from 0. Like the numbers of these persons are 0 all the way up till n minus 1 instead of 1 to n, okay, for this. So there are 2 possibilities for every person. So there are m rounds, there are n person. Like at max, how many persons can have the ball? Let's say before every round, I know that this person is having the ball, this person is having the ball, and this person is having the ball. So can I not create something like can I not create something from using this information? If before every round I have this thing, can I not create another array of having same thing that okay, after this, these persons will have the ball. Like how can you create this thing from after every round from this thing? Anyone having any idea? Like basically the size of this array is n and this is also n. How can we do this? We can simply go iterate through this array. If for the ith person we know that that person has the ball in this round, so there is just 2 possibilities, right? So mark both the possibilities as that these 2 persons can have the ball. And we'll do this for every person in this array or in this that is having the ball. So before every round we have this, and after every round we'll create this, and for the next round this will become this array. Finally, this array is what after n rounds will tell us that which all persons have the ball. So we can just print the number of these persons. Is it making sense? Yes, no? So there are m rounds, and we are in each round we'll iterate once through the array of size n. So our complexity is m into n. Is it clear? What about the others? Is there any doubt in this? See, we know that initially we had this array, except person had the ball. Now, will m times do what? We'll create another array, and from the original array, we'll find, okay, if this person has the ball, then this person can, if it is only counterclockwise, then this person will have the ball. If, let's say, from this, we'll create another array that, okay, I don't know the direction. So this person can throw either at this person or at this person. Now from this, we can create another array. Now we know that the direction is clockwise. So from both, this person will either throw at this person because it's clockwise. So we know that definitely that this person is going to throw at this person, and this person will throw at, let's say, this person. So after 4 rounds, after 3 rounds, first round, second round, and third round, we know that this and this person has the ball. So finally, you have to print this only, right? So what we are doing in each round, we are iterating through the array or we are iterating through the players. If that player has the ball, looking at the direction, just pass it to another person with respect, like considering that this ith person had the ball. Is it clear? Yes, no. What about others? Harsh, is it clear to you? You said that you didn't understand the first time. Is it clear to you now? Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken n, m, and x as input. These are the two arrays that I'll be using. So first, I have initialized my a of, I don't know, just give me a second, my note, like this app just hanged. Okay. In this, I have first initialized my n, m, and x. Then this is like instead of taking the players as 1 to n, I'm taking them from 0 to n minus 1. So initially x minus 1th person has the ball. Then for m rounds, I'm doing this thing. That is, take the distance at which the ball is thrown and the direction. This C is direction. So if it's 0, it's clockwise, 1 is counterclockwise, and question mark means that the direction is not known. So initially in the new array, that is in the next times array B, no one is having the ball. So I'm iterating through my players. If the current person, jth person doesn't have the ball, simply continue. Otherwise, check if the direction is clockwise, that is the ball can be thrown clockwise. In your array B, mark that j plus dth modulo n can have the ball. Otherwise, if the direction is counterclockwise, mark n plus. Now this can be written as you are at jth position and jth position is throwing the ball. D positions counterclockwise. So this is how would you this is how you can calculate this. That n minus. Now how can I, like, how did I come up with this? Like, this is just practice of like how modulo, like how values under modulo work. So from n, just subtract d minus j. Or you can write this down like this also. Like if you take the negative sign inside. So this is giving the ball in counterclockwise direction. Like the jth person is giving the ball in counterclockwise direction. Otherwise, the jth person is giving the ball in clockwise direction. Now it's possible that the j plus dth person, let's say this is the fifth person, like that person is getting ball, like it's possible that he or she might get ball from more than one place in this round, but it's okay. Like we just want to know that it's possible that that person can have the ball. So finally, after doing this for every person, I'm making my array A as my array. Like I'm initializing my array A with the value of array B. Why? Because for the next round, this is the array that will give me the information that which all persons have the ball. So finally, I can print, like after m rounds, I can print how many persons are having this ball and iterate through my person, like players, and if the ith person is having the ball, simply print I plus 1. Is it clear? Yes, no. Yes, yes, I'll share the code. Don't worry about the code. Any doubts? Okay, so let's go to the next problem. So in this problem, we're given that Bernard loves visiting Rodolphe, but he is always running late, and the problem that Bernard has to Bernard has to cross the river on a ferry. Now, Rudolph decided to help him with this, and he decided to solve this problem. Like the problem is that the river is a grid of n rows and m columns, and the at the intersection of the ith row and the jth column contains a number aij. That is the depth of the corresponding cell. Now, all cells in the first column and the last column are banks. So they'll have a depth of 0 like this and this. And Rudolph can choose any row and build a bridge over it. In each cell of the row, you can install a support for the bridge, and the cost of installing such supports at the cell, like installing a support in the cell ij is aij plus 1. So support must be installed so the first following conditions are met. The support must be installed at the first cell and the last cell. Otherwise, the distance between the two pairs of adjacent supports should not be more than d. Like the maximum support distance between two cells should be d cells which are having the support. Now, Rudolph doesn't want to like just build one bridge, but decided to build uh, consecutive K bridges. So this is just an extra information. Like let's look at it later. But first of all, let's try to find how we can like build the bridge for ith row using the minimum cost. So let's take an example. Let's take this example. So let's say in this, let's look at the first one. So we have 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. So here a bridge is required 1. Then we can leave these 4 cells and we can build a support here. So 5 plus 1, 6, and then we can leave these 4 and build a support here. So what is the total cost? It is 8. And this is also the minimum. We can look another way also. This is one. Let's say we decided to build a support here. So it is 2 here. Then let's leave these 4. Here we will build a support 5. And after that, we don't have to build. Like at the last, eventually we have to build a support. There is like no, we cannot leave this. So this way the total is 5 plus 2, 7, plus 1 and plus 1, 9. So 8 is better. And if we look at this thing, So here we'll build a support here. So 1, then we'll leave 4 cells. We'll build a support here. So 1 plus 1, 2, and then leave 4 cells and then build a support here. So this way, if we build bridge over this row, the minimum cost is 4. For this, it was 8. Similarly, we can find for this also. And now this is the value k. Like we need to, if k is 2, Rudolph will build like at least 2 consecutive like bridges. Otherwise, in this case 1, so Rudolph just want to build one bridge. So the minimum value is we are getting for this row. So like this is a very simple problem. See, forget about what is going to happen in like let's look for just one row. You're trying to build bridge over here. So initially you just have one here. If let's say you are here, what like let's say at every position we want the value. What is the minimum cost of bridge to have support like at ith point? The value is support at ith index and the bridge before this exists. Like this means that there is a bridge that like using a bridge you can come from starting from this point to this point. That simply means that there are no more than d points that I'm leaving, like no more than d indices I'm leaving. There is a so what is the minimum value if there is a support here and there is a bridge from starting point to this point. So my ith value is this. So if you want to find this value, what all values do you will you look at? Any idea? You look at the d values before, just the d values before. Why? Because if let's say this is beyond d, you cannot jump from here to here. Like you cannot say that there is a support here and directly there is a support here. This cannot happen. So we just want what is the minimum value in this range, and to that we'll add what will we add? We'll add a of I plus 1 and we'll initialize this value here. So whatever the minimum, because what is our value? Our value is the minimum cost required to build a bridge up till I such that there is a bridge here. So all of these are denoting that only. So we'll just take that minimum of those and we'll initialize. Using that, we'll find the minimum of these. We'll add this thing and we'll initialize it here. So this way we'll calculate this all the way up till here. And finally, what will this give us? That this is, we have a bridge here, and what is the minimum cost for the bridge up till here? We have a support and what is the minimum cost up till here? So like we have somehow have to start with support here, because finally we'll have support here, but initially we need to start such that there is support here. And this way we can calculate for every row what is the minimum cost for having a bridge. After that, the problem is very simple. Let's say we, for every row we have a cost, we just have to find what is the minimum, like minimum sum for a window of size k in this array, in this new array. So this, that is a minimum, like minimum sum constant size window problem. So that can be done easily, but for this, like there are three ways to do this. Either we can use range queries, or the easiest way is just store, like this is also a fixed window of size, right? So just store this in a, let's say in a multi-set, so that you can quickly get the minimum value. And as you are iterating, as my eye will keep on going here, I'll keep removing these values. First I'll remove this, then I'll remove this from my multi-set. So I'll keep on taking the minimum from multi-set, add ai plus 1, initialize this, move to the next point. And when I'm moving to the next point, I'll insert this in my multi-set and remove this from my multi-set. Yes, the d gap means that it can be less than or equal to d. So that's why If I'm at this point, I can choose, if let's say this is my D, I can choose any of these as my previous support, but not beyond this. Is it clear? Gap can be less than or equals to D, not exactly less than or equals to. Is it clear? Any doubts? What about others? Like, okay, it will be clear once I show you the implementation. Just wait. So see, I have first taken N, M, K, and D as input. So N is the number of rows, M is the number of columns, K is the consecutive cells that I find that I need to build bridge over, and D is the minimum gap, the maximum gap. So A is the array which will give me the depth of every cell. This is okay. Now this is the multiset that I'll use to find the minimum. Val is the value that I'm finding for a row, and vals is the final value for every row. Like val of I is will give me for the current row, and vals of I will give me for the ith row what is the minimum cost to build the bridge over it. So for every row, I'm doing this thing. What I'm doing first, I'm making the every value in my val as 0. I'm clearing my multiset. Then since like I have to have a support for the first column, like it will have support the first column. So I'm inserting multiset with 1. That means the first column is having a support. Then I'm starting my index from 1. So this is basically like this is the 0th index. For 0th index, then I'm going starting from first index, and I'm taking the minimum out of my multiset. I'm adding this thing, and that is the value for this thing. My value is the same thing. That is the minimum cost if I have a support at jth index and I have a bridge up till here. Like there's a bridge which using which I can come from first letter 0th index to this index. Then I'm inserting this now new value in my multiset, and this is like if j minus d is more than 1, I can just remove this. Why? Because this point is now more than d distance farther than my jth point. And if j minus d is 1, then I didn't like I don't have it in my val. I could have done it like here also, like that would have been easier. Like this. So my val of u is 1. So for this, like once your some points are getting beyond gap of d, just keep removing those from multiset. Finally, the last value in this val array is the cost of bridge from start to last. So that is the last. I'm inserting it in my, I'm initializing it with this thing, vals of I. Finally, this is like finding the sum of the smallest window, like not smallest window, finding the minimum sum of window of size k. So just take prefix sum, and for every window of size k, just find the sum and get the minimum of it. So okay, let me explain this once again. So val is like what is val of I is the cost of building a bridge up till I such that ith point has a ith index has a bridge. So for calculating val of I just need to look at previous d values. So if my I'm getting beyond this point, I just keep removing these values from my multiset. Otherwise, I'm inserting values in my multiset. So val of last position will give me such that the last index has a bridge, and the what is the minimum cost to build a bridge up till there. So this is what I'll do for every row. And finally, after this point, it's just calculating the minimum sum for a window of size k. Like this code looks complicated, but it's really simple. Believe me. And don't use set instead of multi-set because you can have repeated values also. Why window of size k? Because it's given in the problem that like this thing. Uh, Building just one bridge is boring. Therefore, Rudolph decided to build k bridges on consecutive rows on the river. That is to choose some I, which is between 1 and n minus k plus 1, and independently build a bridge on each of the rows from I to I plus k minus 1. And we need to find the minimum of total cost. So that's why we need to find minimum sum of window of size k. Is it clear now? Any other doubts? Okay, so let's go to the next problem. So in the next problem, given that Rudolph has prepared a set of n problems with complexities a1 to an in increasing order. Now he is not entirely satisfied with the balance, so he wants to add at most one problem to fix it. For this, Rudolph came up with m models of problems and k function. The complexity of the ith model is di, and the complexity of the jth function is fi. To create a problem, he selects the values I and j and combines the ith model with jth function to obtain a problem with difficulty ti plus fj. So the imbalance of the set is defined as follows. Rudolph sorts the complexities of the problems in ascending order and finds the largest value of ai minus 1. That is the difference between two consecutive values. So what is the maximum value for the difference between two consecutive values? So we need to minimize this imbalance by choosing one problem, like by making one problem by this definition. So let me explain this, what is happening. See, we are given an array and we are given two more arrays, B and F. And using these two, like let's say this has n values, this has m values. So using, let's say, ith from here and jth from here, we can get a problem of difficulty di plus fj. And once this, let's say this is x, so this will go somewhere in between here, let's say x. So again, we sort it, then we'll calculate difference of these two, difference of these two, difference of these two, difference of these two, these two, like in sorted order. Let's say this is the order, and we'll find the maximum value that is the imbalance, and we need to minimize this. So tell me one thing. Like let's take one example and then we'll discuss. Let's say this is the example. So in this, we have this is our array. These values are in ascending order. So if we create a problem with the value, let's say 16 plus 5. So what is this? 21. So this value will come in between here. So we'll have 5, 10, 15, 20, 21, and 26. So difference between these two is 5, 5, 5, 1, and 5. So what is the maximum value in difference between consecutive values? It's 5. So this is the imbalance, and this is the minimum that we can get. Let's try to take another value. Let's say we take 14 and 16. So let's take something else, 14 and 3. So we'll get 17. So then we'll have something like 5, 10, 15, 17, 20, 26. So difference is 5, 5, 2, 3, 6. So this way the imbalance is 6. So that's why the minimum that we can get as imbalance is 5. So first of all, is the problem statement clear? Yes, no. Now, like one of the key observations regarding this problem is if this you have your array like this 5, 10, 15, 20, 26. This like if you like if the new problem's difficulty is between this, your final imbalance value won't change. It will remain 6. So what I mean is that the problem that you're trying to create, its difficulty should lie between these two. That is between the two which are farthest, which are having the maximum difference. Because otherwise you're like reducing the difference between these two, but you need to reduce the difference between these two. Is it making sense? That is the difference between the values that are having the maximum difference. So let's say there are these two, and now how to check whether how to check what is the minimum that we can get. It's very simple. See, let's say we are trying to decrease the difference between these two, so we'll try to create values between these two, and this is our array D, this is our array F. So this is the initial difference, and I'm trying to decrease this. So what I can do, I can apply binary search on this. So the maximum difference, in worst case, the difference can be 10 to the power 9. So I can apply binary search on this. This will binary search itself will take log 2 of this value 10 to the power 39, and this will be around 32. And in that I can iterate through my array D. Like for each time when I'm binary iterate, I'll find the mid, and I'm going to check whether it's possible for me to have the difference, maximum differences between these two as mid or not. So in order to check that, what I can do, I can iterate through my array D. And for every value, I can check if there is a F that can give me a difference, that is some D plus F will give me a value which is in between here, such that 20 is here, 26 is here, and the difference between this and this is less than mid. Is it making sense? Is less than or equals to mid. If this is true, then yes, it's possible for me to choose a D and F such that the difference between the maximum difference is divided in values less than or equals to mid. Is it making sense? Yes, no.
Ankit, I just wanted to ask one thing.
Yes.
We can fix this mid value, like whatever it is. For instance, like this is our, let's say the value which is going to lie between 20 and 26.
Yes.
And what we have to do is like we are just going to iterate over this D array, which will be like order of M.
Yes.
And then we have to like binary search again in order to find like some F, which will give us this.
Yes.
Okay,
Yes.
okay.
Then we have to apply binary search
Okay,
to
double
find.
binary search. Okay,
Yes.
okay, okay.
Any other doubts? So after doing this, we'll get yes, whether it's possible or not. If it's possible, then we have that okay, we can distribute this mid. But there is one more thing, last thing. Can someone? The thing is, okay, here you can get the minimum as mid. The difference between these and this is less than or equals to mid. But the thing is, this is, let's say this is your This is your maximum difference. This is your second maximum difference. So your second maximum difference. So your answer should be maximum of mid, or like whatever you are able to break this maximum difference into. Let's say that is some like whatever your value is, comma second maximum. Like anyway, you cannot decrease your final answer, that is the final imbalance value, less than the second maximum difference, because you are not dividing it. You're only dividing the maximum. Now you might say like I'll divide that also, but you can divide only one, because you are adding just one problem. So if you divide that, then anyway your answer is not optimal, because then your answer is the maximum difference. So you're breaking down your maximum difference, and that can be broken down into this two values, out of which maximum is val. So your answer is maximum of val, comma second maximum. Is it clear? Yes, no. Okay. So let me show you the implementation. Like if you do this problem, it will be like you'll find that it's like much more intuitive that way. Like if I'm explaining it, like you might see like we are like what is being done, like we are doing a binary search and then we are iterating over another array, because the problem is framed in such a manner that it's like seems confusing. So in this, I'm taking n, m, and k as input. Then I'm taking the three arrays as input. Then, sorry, okay, something. Okay, anyway, like here I was taking input, and like okay, what I was doing here is that this is like d of I of 0, and I'm iterating through my array, and this d is nothing but my difference. Like this is a pair. Like at ith, this is the index, this is the difference. So it is a pair. The first value is the difference, second value is the index. Why do I need index? Because after this point, I will sort my this difference array according to these values. I'm sorting this. So the first value is the difference, and I'm sorting in reverse direction. And I'm sorting my B and C in ascending order and D in reverse, that is in descending order. So my maximum differences, result one is this thing, and it occurs as this. Now, like I'm using this I. It occurs at ID and ID plus one, and this is the maximum difference. Now, if n is more than 2, then I'm finding the second maximum difference also, which is this thing. Otherwise, it will be 0 only. So initially my result, that is my final, that is the final value that I can break my maximum difference is this only, result one. But I'm iterating, like I have changed the order. I'm first iterating through each of the m values, and from those I'm trying to apply binary search. Like either you can apply this binary search outside, but what I'm doing, I'm applying this binary search inside. So what I'm doing, that L is this thing, like between these two I have to find, right? So ID and ID plus one, these two, I'm finding the mid. I'm finding by lower bound, I'm finding what is the closest value to this thing, mid minus bi. So this is how we are finding. I'm iterating over my array B, and I'm applying binary search on array C. That what is the closest value to mid minus bi? Because finally I want mid. I want something in between these two. So mid. So mid minus bi, mid will be total bi plus ci. So mid minus bi is what I'm trying to look in array C. So like this is just a naive way to do this. I didn't want it to apply, like in binary search, you might get exact value or you might get more, right? So what I'm doing, instead of like checking it like this, I'm just going through the last three and the next three positions. You don't have to do it like this. Like this is completely unnecessary, this loop. You can just take like you just have to do some like if conditions here. Like either this can be completely out of the bounds of C. Like this can be like lower bound can sometimes give you the end iterator also. So you just need to have those conditions here. But otherwise, you can simply do like this. Just the previous and next three. This won't have any effect on time complexity. And just check if this value is more than or equals to L and this value is less than or equals to R. If this is true, like this means that the difference, you are able to divide the difference at least to this mid value, like the maximum difference can be divided into mid, then your result is this thing or maximum of this thing. So what is this thing? Like L minus Bi plus Cj. This is the difficulty of the problems that you are introducing. Minus L. This is the difference between L is nothing but what is L? A of id. Maximum difference was between A of id and A of id plus 1. So now you are introduced this problem. That's difficulty is between A of id and A of id plus 1. So L is A of id. You can write this as A of id. And R is A of id plus 1. So whatever the maximum of these is, you will take it as your result. Finally, after this, all iterating over all of the values of your array B, you will find the maximum of result. You will print the maximum result in result 2. Result 2 is nothing but second maximum. And result is the minimum value that you can break your maximum into. Is it clear? Like this just seems complicated because I have implemented also, like I think I have implemented it also in that way. But the solution is only this much. Just apply binary search, iterate through every value, and take another binary search on your array C to get the closest value to mid. Mid minus bi basically, because you want the value to be closest to mid. Mid is nothing but the mid of difference between mid of, like mid is the middle value between a of id and a of id plus 1. That is the only way to break this into as small as possible sums. Is it clear? Okay. So that's it for today. And thanks for joining. Bye bye.